Consider the following scenario. A survey was conducted to see how healthy students eat in the dining hall. Out of the entire student body, 60% claim they eat healthy. Upon further investigation, 30% of students who reported they eat healthy had pizza for lunch today, whereas 80% of students who reported they do not eat healthy had pizza for lunch today. Let's set up a tree diagram to model this scenario. One way to think about this is to start with 100% of the people at the top and then split them. And we'll split them into two categories: those who eat healthy or claim they eat healthy, and those who claim to not eat healthy. So I'll put not healthy. Look at this statement here. 60% claim that they eat healthy. So this is 60% of the 100%. I'll go ahead and write that in. 60%. And then we can look over here. Well, how many claim they do not eat healthy? If these are the only two options, then this has to add up with 60 to make 100. So that makes it 40%. So now we have two different categories, 60% in one, 40% in the other. Let me move down the page a little bit. Now we will split these two groups into those who ate pizza for lunch today and those who did not have pizza for lunch today, and find those percentages. And the not healthy group, we will also do the same thing. How many had pizza and how many did not have pizza? Well, the statement up here says 30% of the students who reported they eat healthy had pizza. So 30% of this group, in this group, 30% of the 60% had pizza. So what percent of the total would be that group? That's 30% of 60%. And we can calculate that by looking at 0.3 times 0.6, that's 0.18, or 18%. So out of the students surveyed, 18% claim they eat healthy and ate pizza. Well, how many did not eat pizza? We're in this section of the students who claim they eat healthy, and that's 60% of everyone. Well, 18% said they had pizza, so the rest of that 60% would claim that they did not have pizza. 60 minus 18 is 42%. So 40% of those surveyed said that they eat healthy and did not have pizza for lunch today. Now let's look at this side of our tree diagram that has the students who reported not eating healthy. We have this statement: 80% of the students who reported they do not eat healthy, so 80% of these, 40%, had pizza for lunch today. So we can calculate 80% of the 40%. That's 0.8 times 0.4, which is 0.32, or 32%. We can say that of all the students surveyed, 32% of them said they do not eat healthy and had pizza for lunch today. Well, how many did not have pizza? Out of the 40%, 32% had pizza, so the remaining amount would be 8%. 8% of students who report not eating healthy did not have pizza today. Now let's look at the next part. I'll scroll down the page. Use the tree diagram to complete the two-way frequency table below. The first value I'm going to put in is 100% in the bottom right corner, because that represents everyone. And then the two values here should add together to make 100%, and the two values here should add to 100% as well. Right here we have people who claim they eat healthy and had pizza for lunch. Eat healthy and had pizza. That's 18%. So I'll put 18% right here. The next category, how about did not have pizza for lunch and eat healthy? Eat healthy, not pizza, that'd be 42%. If I combine those together, or add them together, those two percentages add up to 60%, which fits with what we saw right here. There are 60% of the people surveyed who said that they eat healthy. Now let's go to the does not eat healthy category. That's 40% of the students, so this would be 40%, and that fits with our bottom row. 60 plus 40 is 100. How many claim they do not eat healthy and had pizza for lunch? Well, this is who does not claim they eat healthy and they had pizza, 32%. So 32% goes right here. And then this last one is does not eat healthy and did not have pizza for lunch. Not healthy, not pizza, 8%. I can check to see my values make sense because 32 plus 8 is 40. And now I can fill in these two by adding across here. 18 plus 32 is 50. So 50% of the students had pizza for lunch. Down here, 42 plus 8 is 50. So then 50% of students did not have pizza for lunch. And these two values add together to equal 100%. Let H be the event that a student reported that they eat healthy, and let B be the event that a student had pizza for lunch. I've crossed out part of this because it said had a pizza bagel for lunch, and I just wanted to make sure that wasn't confusing. So let's just use the same wording we were using in the previous scenario because this is tied into that previous scenario. So a student had pizza for lunch. Find each of the following probabilities. What is the probability of, that symbol means the complement of, so not B is what that would be. What's the probability of not B given H? So what's the probability of not pizza given reporting eating healthy? Let's look at the given H part. Given that they eat healthy means we're only looking at the students who ate healthy, and that's 60% of students. So I'm going to put out of 60% in my denominator. What's the probability of not eating pizza in that category? There are 42% of the students who did not eat pizza, given that they already say they eat healthy. So on the top, I'll put 42%. When you reduce this fraction or type it into a calculator, it's equal to 0.7 or 70%. That means 70% of students who said they eat healthy did not eat pizza. Part 2. What's the probability of not B given not H? What's the probability of not pizza given not healthy? Again, I want to start by realizing that I'm using the people who stated they did not eat healthy. I'm only looking at those students. There are 40% of the students who said they do not eat healthy. So this is out of those 40%. And how many of those did not eat pizza? There were 8% of students who did not eat pizza in that 40% who claim they do not eat healthy. If you reduce that, that's 1/5 or 20%. Number 3, what's the probability of eating pizza for lunch intersecting with eating healthy? So we're looking at the overlap. How many students who ate pizza for lunch also claim they eat healthy? These are the students who ate pizza and claim they eat healthy. And there are 18 students who claim they eat healthy and ate pizza, or 18%. And that's 18% out of the entire population because this doesn't say given. So that's just 18% overall. Number 4, what's the probability of someone eating pizza and claiming they do not eat healthy? 32% of the students claim they do not eat healthy and had pizza. And that's 32% overall. Number 5, what's the probability of B and H? B is eating pizza, H is eating healthy. What's the probability of eating pizza and eating healthy? That's 18% of the total students, plus the probability of eating pizza and not eating healthy. That's 32% of the students. And together, that would be 50%. Number 6, what's the probability of B? What's the probability of eating pizza? We saw that that was 50 out of 100, 50%. Seven, describe what the probability of eating healthy given that you ate pizza represents in the context of this scenario. Then find the probability of eating healthy given that you ate pizza for lunch. So there's a possible description the probability that a student claims that they eat healthy, given that they ate pizza for lunch. And then the calculation of it is going to be a fraction. Given that they ate pizza for lunch, means there are 50% of the people total who ate pizza for lunch. That's my denominator. And then out of those, how many students claim they eat healthy? That would be 18. 18 divided by 50 is 0.36, or 36%. About 10% of children are left-handed. Scientists have developed a test for babies to determine if the child will turn out to be left-handed or right-handed. When a child is left-handed, the test is accurate 92% of the time. When a child is right-handed, the test is accurate 98% of the time. Set up a tree and or two-way frequency table to model the scenario, then answer the questions on the next page. So in these parts of the table, I'm putting that the person is actually left-handed or actually right-handed. And right here, the test they take says they're left-handed, and the test says they're right-handed. 100% of the people is over here, and then 10% of children are left-handed. So actually left-handed should add up to 10%. Let's look at this part here, 92% accurate. So when a child is left-handed, the test says they are left-handed 92% of the time. So out of the 10% of children who are actually left-handed, 92% of them will be tested as left-handed. So we would do 92% of 10%, and that's 9.2%. That leaves the remaining 0.8%, or 10 minus 9.2 on this side. Now let's look at this 98%. When a child is actually right-handed, that's 90% of children. 98% of them will have the test say they are right-handed. So this is 98% of 90%. So 0.98 times 0.9. That's 88.2%. Now of the 90%, if I take away the 88.2, I get 1.8%. So this tells us that 1.8% of kids will have a test that says they're left-handed, but they're actually right-handed. And 0.8% of kids will have a test that says they're right-handed, but they're actually left-handed.